Okay. Hello again to Calculus 3 and our live session. In these live sessions, they are a place where you can ask questions about the content, about homework, about organizational stuff, but it's also a place where I'm going to pose like small little exercises, and then you can try to solve them, and then we try to solve them together, and maybe that, provokes more questions, more discussion, and that's the general idea. I assume that some of you are wondering, okay, how's the whole WebAssign licensing thing gonna go? How do I get my license? I still don't have any news from the publisher. They're still working on, I'm actually not quite sure what they're working on, but they told me they'll send me an email today telling me what to tell you on what you might need to buy or not, but I hope to get the information to you by the end of the day. Apart from that, do any of you have any questions about the material so far, about anything basically? Yes, please, just unmute yourself.
Hello, doctor.
Good morning.
Regarding the test 1 date, it will be as the same date as Islamic, but the Islamic is from 4 to 5:30. But also there is another test which is Stat 273. It's also the same time as the math from 11 to 12.
Yes, I know. So we are definitely going to move our test. I'm not quite sure to when, but I think we'll figure that out in a day or two. I just want to wait until, maybe everything else is settled and we know when all the other tests are going to be, because I don't want to move or have to move the test again and again and again because there are new collisions and new collisions. But I'll make sure that there are no collisions. Yeah. So don't worry about that. Anything else? Question from the textbook. Okay. That is actually a good question if I can, because I have a different edition of the textbook, so I'm not quite sure if I'll have access to the same question. What's the question you're looking at? 12.1.24. Could you just verbally tell me what the question is? So that because I have a different edition of the textbook, I'm not sure if I see the same question as you do. The numbers changed. No, just a minute. Okay, you know what? We're gonna start with exercise that I've already prepared, and then we can come back to yours later, so you have a bit of time to prepare that. So let me start sharing my screen.
Doctor?
Yes.
There was something also about the tries that we have in WebAssign, if it's possible to make it more than 2, so we can try more than 2 times.
Yeah, so for the time being, plenty of those questions are multiple choice questions where there's only 4 possible answers. So giving something like 4 tries would kind of make them pointless. I think for the time being, we'll stick with 2 tries, and we'll reassess that after, maybe the first 1 or 2 weeks, and then we'll see how it's going, if that's all right.
Okay, thank you so much, Doctor.
You're very welcome. Okay, so things I have prepared, where are we? Okay. I want you to consider the following exercise, and don't start directly solving it, just consider it for a moment. And we want to consider the triangle that has as endpoints P, Q, and R with those coordinates right here. And we wonder, on the one hand, what are the angles of this triangle? And to make computations a bit easier, we're not going to take a look at the actual angles, just at the cosines of the angles. And the other question is, what are the lengths of each side of this triangle? And what I would like you to do is I would like you to think for a moment or two, think for, let's say, 2 minutes on how to solve it. Don't directly get into the actual numbers. Just make a plan. What's the first thing that you need to do? What's the second thing that you need to do? What's the third thing you need to do? Okay, so just do that for something like 2 minutes, make a plan, and then we'll talk about it.
Doctor, when I'm taking the length of each side, do I just take the distance from P to Q and then Q to R and then P to R?
Yes, that sounds like a plan.
Okay.
That actually does sound like you have a plan. So if we wanted to solve this exercise, who can give me like an overview? What's the first step that we need to do? What's the second step? What's the third step? What do we need to do?
Doctor, draw a right angle triangle.
Sorry?
Yeah, draw a right angle triangle and make PQR.
Okay, why do you think it's a right angle triangle?
Because from the we make right angle triangle and we assign it PQR, and then we will find the length of PQ like this.
Okay, yeah, actually, it's going to turn out to be like this, but I think you're way ahead of us. I think I want to start a bit slower just to do this very, very methodically.
Yes, sorry about that.
No, everything's fine. As you said, of course, like drawing a picture is maybe a good way to visualize this. Now, this is a very, very schematic picture. These are definitely not the actual points we'll be looking at. So our triangle might look something like this, right? We don't know yet. I mean, okay, actually, we know it definitely does not look like this, but just to have an idea of what we'll be looking at. And then somebody in chat says that the first thing that we should do is find the vectors. And that's a very, very good point. So if we have a triangle with 3 points, P, Q, and R, then of course, these are like very, very fixed positions in space. But of course, the triangle doesn't change no matter where we move the whole triangle, as long as we move the whole triangle, all of those 3 endpoints in the same fashion. The first step to find the vectors is then to find the connecting vectors, because those are then actually independent on where we move the triangle in space. So first, find the connecting vectors. Okay, there's now more going on in chat. Then find the magnitude of each vector. Yes, that's a very good point. Compute their lengths. Because if we compute their lengths, then, well, the lengths of the connecting vectors are exactly the length of the side of the triangle, which, I mean, we can directly see from the diagram. Now, what is then step number 3? Now, there was a question in chat, what do I mean by the cosines? So what we have, of course, in the triangle are 3 angles, alpha, beta, and gamma. And we know that the sum of these 3 is 180 degrees. And I want us to compute these angles. And what we're going to do instead is we're not going to compute the angles themselves, but we're going to compute cosine of alpha, cosine of beta, and cosine of gamma, because that's actually what the formula yields us. And then if we wanted to get to the actual angles, we would use Arcus cosine and just get the actual angle, but that's just going to complicate the calculation more than it actually provides us any insight. So how do we get to the angles, or at least the cosine of the angles? What's the magic strategy for that?
Like some sine is equal to perpendicular by hypotenuse.
Okay, you want to do it with geometry? That's absolutely possible. But that's not quite the way I want to go, because I'd like us to use the content that we are currently discussing in the lecture.
The dot
absolutely,
product?
yes, the dot product. But of course, you're absolutely right. We can just use regular geometry and compute the angles with these results, but we have the dot product, and we had a great formula for the dot product, and compute the angles via, and now the formula was that if we have 2 vectors, A and B, build the dot product, then that is almost the cosine of the angle between them, but we have to divide by their length. This is the angle between A and B. Okay, now I'd like you to take, let's say, 3 minutes and actually do these 3 steps for this triangle. And if you have any like intermediate results, just post them in chat so I can see where you're at.
Doctor, in this
Yes.
lesson we'll be working with degrees, right? Not radians?
I honestly don't care. Either one is
Okay.
fine.
Okay, thank you.
Doctor,
Yes.
can you share the screen, please? Can see
Sorry.
the
Oh, did the screen share stop?
yes, we can see the coordinates.
Oh, sorry. Is it now back?
Yes, Doctor.
Okay. Okay. So I hope you started working on this, and now we'll more or less do it together. I think I'm just going to show you how I would do the whole thing. So for step 1, we need to find the connecting vectors between P, Q, and R. So how do we get from P to Q? Well, intuitively, the idea is if we start at P and we want to get to, Q, then we do this again component-wise. So to get from -2 to 1, we need to add 3. If we want to get from -1 to -2, we need to subtract 1. And if we want to get from 1 to 4, we need to add 3. Of course, if you want to do this a bit more formally, then of course you can also just take the vectors corresponding to the points. So in this case, R is 5, 8, -3, and then subtract the vector corresponding to P, so -2, -1, 1. And that gives us 7, 9, -4, if I'm not mistaken. And we need one more. We need RQ. So this is 1 - 2, 4 minus 5, 8, -3, which is -4, -10, 7, if I'm not mistaken. Does anyone have a result that's fundamentally different and they are confident in that? Or did I compute this correctly? Well, let's hope I computed the whole thing correctly. I see results for, and I remember actually the length of the vectors. So now we compute the length of these vectors. So we just, for example, for the connecting vector from P to Q, this is now this vector. So what do we need to do? We square 3, we add the square of -1, and we add the square of 3 again, and then we take the square root out of the whole thing, and this is now the square root of 19. The distance from P to R is, well, we square 7, which is 49, we square 9, which is 81, and we square -4, which is 16, and we take the square root out of that, and if we add this is 90, 130, 146, if I'm not mistaken. And then we take the length from R to Q. This is now 16 plus 100 plus 49. So this is the square root of 165. So far, so good. Any questions so far?
All clear.
Okay, perfect. So this already gives us the length. Now we want to compute the angles via this formula. And we know it's not going to be pretty because we know that the length of these vectors are nasty square root of something, so this is not going to be too much fun. But at least we're going to compute the dot products. So first we're going to compute the dot product of PQ and PR, which gives us the angle, like this is PQ and this is PR, so it gives us this angle. If we divide by and take arc as cosine. So this was 3 minus 1, 3. And the other one is 7, 9 minus 4. So what do? Well, we multiply these two together. This is 21. And then we add the result of the multiplication of these two, which is minus 9. And we add the result of the multiplication of these two, which is minus 12. And this is 0. So this is actually a bit of a special result. We're going to talk about that in a bit. Then we want to take a look at this angle. So this is going from R to P and then from R to Q. So what is RP? Well, PR is this one. So RP is minus that one. So we have minus 7, minus 9, 4. And RQ is this one. So minus 4, minus 10, 7. So this gives us 28 plus 90 plus 28 again. So this is 90 plus 56. So this is 146. And then we need this last angle. For the last angle over here, we have QP and QR. We know that PQ is 3 minus 1, 3. So QP is minus 3, 1, minus 3. And now QR, where do we have QR? This is minus this one, so it's 4, 10, minus 7. And this is minus 12 plus 10 plus 21, which is 19. And to get to the angles, so for example, if we wanted to take a look at the angle between PQ and PR, I think, how do we call this? Like, I think sometimes you write something like this: angle of PQ PR is the dot product. Oh, well, no, is, okay, sorry. Let's move it a bit over here. So first we find the cosine of that thing. So PQ and the length of PR. Well, this is now just the cosine of the angle. So we actually need to build Arca's cosine of that thing. But we already know that these two had dot product 0. So no matter what we divide it by, it's still 0. So this is Arca's cosine of 0 degrees, for example, if you want. And then this is, no, not of 0 degrees, 0. And this is 90 degrees. So we know we have a right triangle. And you can, of course, then do the same thing for the other results as well. So like you can, of course, use this same formula with these other points, and then you would get other results for the angles. And I hope it's all right if we don't bother with those details too much. Any questions to that?
Doctor, can you please go up to the question? Go to the top. Doctor, they are asking to find the cosine of the angle, but finding the theta and finding the cosine, is it same if we do it by sine, or if we like what is the difference between finding the angle and finding the cosine? Is it same?
It's almost the same. Like the difference is, do you find this thing or do you find this thing? So if we compute the dot product and divide it by the length, so if we compute this, we get the cosine of the angle. So in this case, for example, we would get 0. And if we want to find the actual angle, then we would take Arcus cosine and we would get 90 degrees. But the difference between finding the cosine of the angle or the angle is just one application of Arcus cosine or one application of cosine, and that's why I kind of use them interchangeably. If we take, for example, a look for the, if we wanted to like take a look at this angle, then this is Arcus cosine of what? Well, of this thing for the corresponding things, and the, what do we have? The dot product of RP and RQ. We have that. This is 146, and now we need to divide it by the lengths, and the lengths are square root of 146 and square root of 165. And so if you wanted to find the angle, it is Arcus cosine of 146 divided by multiplication result of that thing, and that's just pointless to actually write it down like this. So we're gonna end up at the, we just would end there. But yeah, that's all what I meant. Sorry for the confusion. Any more questions?
All clear.
Okay, then let's stop with the triangle exercise and take a look at another thing. What I would like you to think about is a strategy. Imagine you have two vectors, for example, given by 1, 2, -1, and another one given by 4, 0, and 3. How would you find a vector which is orthogonal to both of them?
Use cross product.
Exactly, just use the cross product. Now, I don't know how comfortable you feel with computing the cross product, so I thought we'd just do this together quite quickly. The way I think is much easier to remember is different from the one that's being taught in the textbook. What I like to do is the following. So we want to compute the cross product 1, 2, -1, and 4, 0, 3. And for that, we compute the determinant, where in the first row, we write our unit vectors. In the second row, we write our first vector, and in the third one, our second. And now we need to compute this determinant. And computing the determinant is just computing, if you remember, lots of diagonals. So we take this diagonal, and you take this diagonal, and you take that diagonal, and you add them all up. And then you take this diagonal, and you take that diagonal, and then you take this diagonal, and you subtract them. And that's what gives you the whole thing. So if we do this in this example, the first diagonal we're going to look at is this one. And this gives us 2 times 3 times I. So we have 6. But there's one more diagonal that involves the I, and this is that one. And this is 0 times -1 times I, so this gives us +0. Or minus, maybe I should write mine, well, that's 0, whatever. Plus, what do we have for the j? For the j, we have this diagonal. which gives us -4. And then we have another diagonal involving the j, which is this one, if you can make it out. And this is now 3, but it's minus because the other diagonals are with a minus sign. So this is -3. And now we're running out of color, I think. Yeah. So let's take pink for this one. So we have the k diagonal. There we have this one, but there's a 0. So we get a 0 here. And then we have one more diagonal involving the k, which is this one. And this gives us 8k, but because it's one of those diagonals, it's minus, so minus 8k. Which is then, well, let's write it without the ijk. This is then 6 minus 7 minus 8. Now, quick sanity check: is this vector actually orthogonal on the two vectors that we started with? Well, let's just compute the dot product. 6 minus 7 minus 8 dot 1 2 minus 1. Again, multiplying the first component gives us the 6. Then we have minus 14, and we have minus plus 8, and that is actually 0. And then we have 6 minus 7 minus 8 dot 403. And this gives us 24 plus 0 minus 24, which is 0. And if the result of the dot product of two vectors is 0, then they are actually orthogonal. And so, yes, we actually did find a vector that is orthogonal on both these. Do you have any questions concerning the dot product, the cross product?
Doctor, what is the meaning of orthogonal?
Like a right angle between them.
Okay.
Perpendicular, maybe.
Okay, so that means after finding the cross product, like we will check if the dot product becomes 0. So that means it is orthogonal, right?
Exactly.
Yeah. Thank you very much, doctor.
So yeah, being orthogonal just means, you got like a right angle between them.
So, doctor, talking about cross product, I have another way to find the answer. Is it okay or?
Absolutely. Absolutely. Well, as long as it's correct.
This is
yes.
this is a bit complicated. The other one is a bit easier.
Ah, you find so? Okay. I personally think that the mnemonic about the diagonals is easier, but again, this is just, there's many different ways of computing it. Really, just choose the one that you prefer.
Yes, doctor, because we took in static last course easier way, but when I did it now, the easier way, it gave me the same answer.
Of course. It's in the end, it's the same method. It's the same cross product. Really, you can do it however you want to. Any more questions to that?
All clear.
Okay, if that is not the case, then there was like a question from way earlier about your exercise in the book, and was about finding an equation of a sphere with a certain center that is contained somewhere. I personally would prefer us if we all avoided finding equations for spheres, because I don't think there's actually much insight. And if it's all right, we're just not gonna be looking at that because it's just computationally complicated without actually providing any insight from my perspective. Unless if you're really interested, then of course I can also like record a small video about what you do about spheres. Yeah, maybe I should just do that. And answer that question in a different video. Yeah, I think I'll do that, if that's all right. Okay. Okay, any more questions?
Doctor, in the group, they were saying that if we had test 1 after the Eid holiday, it will be better because if we will move it.
Yeah, so we will definitely move the test. I haven't quite decided on which date yet because there's other tests that it might collide with, and it should also be that both test 1 and 2 have approximately the same amount of content. But yeah, we'll figure it out soon.
Okay, thank you so much, Doctor.
You're very welcome.
Doctor, is our
Yes.
book Thomas Calculus or the other one?
The other one, the Stewart one.
Okay, not the Thomas Calculus.
No, the Stewart Calculus metric version 8th edition, to be precise.
Okay.
But content-wise, they should include pretty much the same thing. So please, I mean, we will need to worry about the WebAssign licenses as soon as we get the information from the publisher. But please don't think that you actually need to take a look in a different book than the one you're already comfortable with, because they pretty much include the same content and the homework is going to be online anyways.
Yeah, thank you, Doctor.
You are very welcome. Any more questions?
Doctor?
Yes, please.
How can we access the web assignment and I don't have a code?
Can you log in onto WebAssign? Hello?
Yes, Doctor.
Well, then it's just gonna, I mean, again, if you haven't gotten a code yet, you'll get the information hopefully later today as soon as the publisher sends me that email. As soon as I have that information, we'll see a new post in general explaining all of that.
Doctor, is there any other kinds of questions that we need to avoid?
What do you mean need to avoid?
You told us that questions with finding equations of spheres, we could avoid them. So are there any others?
Generally, just look at the homework. I mean, what's going to be in the homework is the content of the exam, and it's the same as the content of the recorded videos. So I didn't explain how to do the whole sphere thing in a video, so you can be safe to assume that, yes, you can avoid that.
Okay, thank you so much, Doctor.
So, Doctor, the ideas on the homework will be enough?
Yes, I mean, of course, the homework is going to it's going to cover every subject that I want you to know and to learn. Yes. I'll not bring questions for you in the test or the exam that you have, like where you've never even seen the type of question before. Absolutely not.
Okay, thank you.
Of course.
Excuse me, doctor. I'm asking about the license. Should I buy the book from the university, or can I get it online or something like that?
As I said, you will see a post in general about all of that as soon as I have information from the publisher.
Yeah, okay. Thank you, doctor.
You are welcome. Okay. Any more questions that need answering? If not, then I think that is it for today. I wish you a nice Thursday and a great weekend, and we'll see each other again on Sunday, hopefully. So yeah, have a good day. See you soon.
Thank you so much, Doctor.
Thank you, Doctor.
Have a great day.
You too, Doctor.
Thank you,
Thank you
Doctor.
so much.
Goodbye.
Goodbye, Doctor.
much.